In exercise 3A, we're going to outline some important definitions that actually set the scene for the rest of the motion chapter. Now, as you can see from the title of 3A, it's called average velocity and average speed. Now, in our casual language, we probably interchange those words, velocity and speed. Sometimes we think we're talking about the same thing. However, in the mathematics context, they're not the same. So that's the sorts of things that we're going to establish here in this first exercise. But before that, because velocity and speed rely on some other dimensions, then we need to introduce those and make sure you understand them. It's important that you understand displacement. So what is displacement? So by definition, it's the position of a particle relative to a fixed point. Now, we probably haven't spoken about that sort of concept before. We've talked about distance. Now, it's really important that you realise displacement and distance may not be the same thing. So let's focus on what displacement actually is. Because it's relative to a fixed point, then it has, as it says here, magnitude, which is a size, and more importantly, it has a direction. We could have displacement graphed on this horizontal line here. Here is usually the fixed position is called the origin, or at zero, and because we know if we're in a position to the right of that, we would call it positive, and to the left we can call it negative. Or if our displacement was on a vertical line, again we've got our fixed position, which gives us direction in, and we know that we would be going up from our original position if our displacement was positive. So there's a big difference between a displacement of 3 and a displacement of -3. We'll talk more about the difference between displacement and distance as we move through the exercise. So, having established what displacement is, let's move into average velocity. And average velocity, you know the word average. Average velocity is the change in displacement divided by the change in time. So, if our change in displacement was from this location, was at 1, and we finished at -2, then the change in displacement is a change of -3. A quick tip for getting the change in displacement is to take where you finish minus where you started. So from -2 minus where we started, which was at +1, gives us -3. You could probably see that if we started at 1, it doesn't matter where we went, maybe down to -5, and finished back at 1, then it's possible, although there's been velocity, our change in displacement has actually been 0. We finished at 1 and started at 1, and 1 subtract 1 is 0. Our average velocity is 0. So it's because it's dependent so much on the direction, then it brings up these quite different concepts, I think, that we're used to, especially if we talked about speed. And hopefully you can see already that it's not okay to interchange the two, that velocity is not the same as speed. Instantaneous velocity, on the other hand, and it's important that you see the difference between instantaneous. So at some instant on its way down here to -5, we could calculate the velocity, but to do that we will need to use some calculus, because it's at a particular moment in time. So it's change in displacement with respect to the change in time. And that's, of course, our calculus. So you'll see that. Distance is another term that we have to make sure that we've got defined. So we define displacement. It's got magnitude and direction, position relative to a fixed position. Whereas distance is just how far the particle has moved. So in this last example, when we started at 1, went to -5 and came back, the displacement was 0, but the actual distance travelled is 12 units. There's no denying that. And getting down here, it's 6 units. Back here, another 6. If we started the speedo and went down and came back, then the speedo would have recorded 12 units. So the distance is a different concept to displacement. And again, really important that you get those differences. Think about, for distance, think about the speedo in a car. It doesn't know where you've been, where you end up. It just records how far you've travelled. And it's always a positive number, and we start at 0. We don't talk about a negative distance. Now on to some terms you would be familiar with. The average speed. Average speed is the total distance travelled divided by the total time. Now you've used that formula for a long, long time. So we then talk about the instantaneous speed. We know that we could have an average speed. Between home and school, we would end up with an average speed. But at any one instant, we might be going 40 kilometres an hour or 60 kilometres an hour. So that's a different concept, instantaneous speed. And again, it depends on the velocity actually. So we will come across our evaluation of instantaneous speed after we've done velocity. Some other important changes to note are we're going to be drawing graphs. Now, the thing is that most of our graphs will have as the independent variable time. Time will be the independent variable. So time gets recorded on the horizontal axis. So this is time. We no longer call that axis x-axis, and we no longer call this axis the y-axis. But what becomes quite confusing is that for some reason the scientists chose to call displacement, or they chose to use the letter x. So if I'm graphing displacement here, rather than calling it d for distance, they're going to call it x. If you see an x on this axis, you now have to realise you are measuring displacement on that axis. And like I said, almost the most common thing that will occur on the horizontal axis will be time. We don't talk about negative time, and so our axes are fairly limited. Displacement is often graphed on the vertical axis, but it's not the only thing, so we have to be careful. We might have displacement, we might have velocity there, we might have acceleration. We just have to be aware of what we are actually recording on our vertical axis. You'll hear a lot about this change in. So you heard that first introduced back here. where average velocity is the change in displacement. The symbol we use is this delta, which is just a Greek symbol, and so if you see this triangle, you'll know it's referring to a change. And it's just reinforcing the concept that time is always on the x-axis and negative values of time are excluded unless it specifically says. This becomes a nice little summary. We've got our distinguishing between our average and our instantaneous, and distinguishing between speed and velocity. Average speed is what we're familiar with, distance over time, change in the distance over change in the time. Velocity is the change in position over change in time, and that's when we could get a zero, because in the end we might be back where we started, and so there's no change in the position. However, there has been a change in displacement. I'm actually going to take that out. I'll take that out. I don't really like that. Leave it like that. Instantaneous speed is where we are going to start our calculus, and we'll differentiate our displacement with respect to time, and we'll introduce that more slowly. And velocity is, and because speed is instantaneous speed, we're not concerned about which direction we're going in. We're just concerned about the magnitude, so we don't need positive or negative. Whereas on velocity, we do need to know the direction, if it's a positive velocity or a negative velocity, and so we wouldn't have absolute value for velocity. Okay, let's have a look at this example. If you haven't had a chance to fill out the table, then you might want to pause the video and fill yours out and have a think about the situation. So a particle moves according to the equation. X, remember, X is the displacement. Its position relative to the origin moves under this 4t minus t squared. Now, you probably can see that that's a familiar function. It's quadratic. It's a negative quadratic, which means it's upside down. When we graph the graph of time on the horizontal, x on the vertical, we should get an upside down parabola. Now, apart from that, it says where distance is in metres and time is in seconds. Complete the table of values. So remember, we've already moved into time taking up the spot of usually our x, and x moving into where we would have normally recorded and graphed the y variable. So when t is 0, you can see that x would be 0, so it's starting at the origin. It's moving after 1 second, it's moved to a displacement of 3 units. Plus 3, it's moving in the positive direction away. At 2 seconds, it gets to a displacement of 4, but at 3 seconds, it's come back to 3, and at 4 seconds, it's back to 0. It says, hence find the average velocity of that the particle moves. The average velocity, remember, is the change in displacement from where it finishes. So at t is 2, it finishes at 4, subtract where it started over the change in time. So we're at 1 metre per second. I'm probably going to have to stop the video and continue on with a new video. Sorry about that.